Okay, in this presentation we have a membership table here. So we have the sets A, B, C, and we have the subsets X, Y, and Z. Okay, so I'll become a little bit clearer shortly, but essentially what we want to do is express the sets X, Y, and Z in terms of A, B, and C, and we have this membership table to help us. So it's a complete membership table for A, B, and C. Everything should be just in shot there now. But essentially we have full membership table there for A, B, and C, 0, 1, 0, 1, 0, 1, 0, 1. So that's the C properly sort of laid out, alternating every second entry. 0, 0, 1, 1, 0, 0, 1, 1, alternating every second entry, or every second pair of entries, and 0, 0, 0, 0, 1, 1, 1, 1. So it's just skips every 4. Okay. So here we have X, the sort of membership table for X, membership table for Y, membership table for Z. What we're going to do is sketch them out on a big Venn diagram and just try and simplify or come up with very simple expressions for X, Y, and Z in terms of A, B, and C. So the question actually formally is, just like bring it up there. There we go. Describe each of the subsets X, Y, and Z in terms of A, B, and C using union, intersection operations with set complements and set difference. Okay. So what we're going to do is start off with Z. So I'm just going to start off with X. So I'm just going to bring this into shot here. There we have it there. So this is the membership table for X, okay, or the Venn diagram for X. And what I'm going to do is actually just fill it in bit by bit. And I'm going to use a very different colored, I'm going to use highlighters and pens and so on just to actually sort of get across something there. So I'll just so first off, the first entry for X is 0, 1, 1, okay, 0, 1, 1, okay, so that is not in A but in B and in C simultaneously. So that is this region here. Okay, so that's the 0, 1, 1 region. It's not in A, but it is in A, B, and C simultaneously. Okay, so let's go on to the next one there. A and B. So this is it here. So it's in A and B, but not C. Okay. So I'm going to use red pen in this particular instance. So it's this region here. Okay. And then finally, the last entry, just bring that back in there. It's this one here. It's in the intersection of all three, the 1, 1, 1 region. Okay, which is in the region that's encapsulated by A, B, and C simultaneously, which is the intersection region. So I'm just going to sort of highlight it in there. Okay, so I'm going to highlight it in red and in yellow, in orange. There's simultaneously. The reason is that actually just to sort of try and sort of highlight the fact as much as possible that the shaded region we have here is the union of the intersection of B and C. So the intersection of B and C is everything that is in orange, that got covered by orange here. So these two regions here, that's B and C, B intersection C, union this region here and this region here. Okay, collectively, everything I shaded in red, including the intersection region there of all three, that is the intersection of A and B. Okay, so that is how we could sort of express X. It's the union of the intersection of B and C and the intersection of A and B, or A and B and C if you prefer. Okay. Good stuff. Now, so what we're going to do actually is go on to Y now. Okay, so I'm going to back here to Y. So essentially what I have here is the first entry is already filled in. It's 0, 0, 0. And that is actually everything that is outside our Venn diagrams. The 0, 0, 0 region is everything that's not in A, not in B, and not in C. So it's essentially outside our outside our regions here altogether. So that's the first part of it. So that's the first one shaded in. Okay, so let's go back here. So the next one is this one here. So this is the second entry, and it's the C only region. So we're going to fill that in. Okay. The C only region is the 011 region. It's this one here. So it's in C, but not outside of A, outside of B. Okay. So the next entry for Y is here. This is the A only region. Okay, the 100 region, which is A only. Okay, so let's fill that in. There we go. Not doing a great job, but there you go. That's the general idea there. Okay. And then finally, the A, this is the last one here. So this is the A and C. So the 101, which is A and C, but not B. And I'll just use a different color pen this time, just to emphasize it there. So it's that one there, the 101 region. Okay, so that's all 4 regions. Okay. And essentially what you're looking at there is the only thing that I've not filled in is B. So essentially this actually works out to be the complement of B. Very simple. So I'll just actually write that in there, the complement of B. Okay, and that's what all that Y is. Now we're thinking, actually, was that a bit overkill? And it's no harm to just double check with the Venn diagrams. Okay, but actually let's go back here. So the B, like when we specify it on the membership table, 0011 0011. But let's look at Y. It's 11001100. Okay, so it's actually the opposite of what B is. So actually, if we sort of paid a little bit of extra special attention there, we probably would have picked it up directly. You probably still have to show your workings though anyway, so it's sort of no harm to do the Venn diagram like that. Okay, so that's grand. So the next one now is, I'm just going to move this out of the way, this page here, and I'm going to just leave a setup for the next one, which is Z or Z if you prefer. Okay, there we have it there. So what we're going to do here now is just look at Z or Z. Okay, so we have 5 entries. Okay, the first one is the C only region. Okay, so this one here, the 001 region, as in C only. The B only region, okay, 010, if you prefer. Okay. The intersection of A and B, or B and C, but the part that does not include A. So this region here. Okay. So that's the first 3. So let's look at the last 2. A and B, but not C. 110. A and B, but not C. Okay. I'm going to fill that one in here like this. A and B, but not C. And A and B, and then the intersection of all 3. Okay. Okay. So that's it. That is, so essentially what we have here is, well, obviously it's going to be B union something. Okay. So union of what though? Okay. So I argue that it is B minus, or sorry, the set difference of C minus A. Okay, and that is, somebody's trying to chat to me on Facebook. That is this region here. I'll just sort of fill it in, highlight it in there. That is the C minus A region there, what I'm just highlighting in here now. Okay. So, there is other ways of approaching it, but that's actually, I think, the simplest. So, that's grand. We'll leave that there.